Hi everyone, today I'm going to show you how to make a simple menu that you can use on any display with any Arduino. My example is based around 3 buttons. I use 3 buttons just because it uses less resources and I find it more elegant when implementing my prototypes. I don't see the need for 5. However, you may change this as required once you've examined the code. To start off, we first need to declare some pins for our buttons. Here I'm using analog pins. They're set as constant bytes compared to some people using a define statement. I don't like the define statement because it's a preprocessor. It wouldn't flag any errors when you compile the code. It's generally the define statement should generally be avoided. We don't want to use an int to define our pins because an int uses 2 bytes, and we have no need to do that because an Arduino has certainly less than 255. So we're going to use a byte and we're going to use a constant because it's never going to change. So we're using constant bytes to declare our pins. I'm using analog pins for my buttons because I'm using a Uno and I don't have many digital pins spare. However, you can use a digital pin for your buttons if you wish. Next, to explain the variables we see here, I have 2 variables to adjust variables themselves. So these 2 variables by default are 1 and 0.1. These will be used to navigate through the menu and to adjust any variable that you may implement, even if it's a bool, a byte, a float, a long, anything. We'll be using these, which I'll show later on, to adjust the variables. We've got a billion here, which is labeled as a bool, called menu lock, which is going to be used to lock the menu in place, which is attached to the select button. I'll describe this in a minute. We have a byte, which is going to track the position of the menu. By default, it starts at 0, which would be your home page, where you display your general data. And a constant byte to declare the maximum amount of rows we wish to implement. In my case, for this example, I'm just going to have 4 rows because it's a lot quicker. You could have 100 rows if you wish. And I've, just for demonstration purposes, created 3 variables for us to adjust for demonstration purposes. In the setup, I've declared the serial monitor at 115,200 baud rate, pardon me, and we have declared the pin mode for 3 pins, set to input the 3 pins of our down, select and up button. Again, set to inputs. In the loop, you'll notice there's only 2 functions called, and you'll be thinking, well, where are they? Well, they're in new tabs, because it makes the code a lot neater. We can refer to it a lot quicker and go, oh, there's the menu code there, there's the navigation code, it's there. If you're unsure how to make a new tab, which is what they're called, you go to this arrow up here, click New Tab, label it whatever you wish. It's not referred to anywhere in the code, you don't need to import it, just call it whatever you want, and then click OK. Again, I've already created mine, so I don't need to do that. Looking at the button statement, that is in our navigation. Here we go. You can see that it's referring to the state of the buttons. I'll break this down for you. So it's saying if digital read down button equals high, so if it's detecting a voltage, do these, I'll explain in a second. Else if the up button equals high, so down, up, or select button. Now, breaking that down further, if the down button is pressed, print it out to the monitor, just for debugging. Set these 2 intervals that I explained earlier. Set the int interval to -1, notice the minus sign there. Set it to -1 and set the float interval to -0.1. You may want to change that to whatever you wish, and you could change it in runtime, it's not a constant. But by default, when you press the down button, a float will decrease by 0.1 and a float, an int or a byte, will decrease by -1. And this is also in the down button, so if you've pressed down, it will set these to minus. And if the menu lock is false, call menu navigation, else if menu lock is true, call adjust values. I'll explain that in a second. And with a delay, as a simple debounce to stop it calling this function over and over, because you may hold the button down for, let's say, 100 milliseconds. You wouldn't want it calling this 50 times, so we've got a 200 millisecond delay. The same is to be said for the up button. However, the int interval and the float interval is set to a positive 1 and a positive 0.1 compared to minus. I'll explain what they're doing more in a minute. The same is to be said if menu lock is false. Call the menu navigation if you're pressing up. Else, if the menu lock is true, call the adjust values when you're pressing up. Now this is set in the select button. If you press the select button, if the menu row is greater than 0, now this is said because, as I said earlier, row 0 is the home page. We don't want you pressing the select button on the home page and it trying to do something, because all the home page is doing is just displaying data. You could put an else statement in here later on if you wish to have the select button do something in the home page, but for now it's doing nothing. So it's saying if the menu row is greater than 0, if the menu row is greater than or equal to the max rows, which was set to 4, take the menu home, which is what it's saying. So if the menu is at the end of the menu and you press select, take the menu home. And in the menu here, you'll say that's actually going to be a return sign, or it would say exit menu in text. So that's what that is doing. So it's saying if you're at the end of the menu and you press select, set the menu row back to 0, being the home page. Else, if you're not, so if the right menu is greater than 0, so let's say if you're in menu row 1, this is obviously going to be false because you're not at the end of the menu. Set the menu lock to its opposite state. This is what it is saying. If the menu lock equals, no, if false, sorry, what's the better way of saying this? False equals not false. So false equals not false would be true, and true equals, that's it, yes. True equals not true, so false. False equals not false, so true. So this is swapping the state of the boolean. Boolean equals not boolean, essentially. That's a better way of saying it. Sorry about that. So if the menu row is greater than 0 and you press select, if you're not at the end of the menu, set the menu lock to its opposite state. So if the menu lock is false, and then they press up or down, which is the default state by the way, menu lock is set to false by default. If they press up or down, it will call menu navigation, and if it is true, it will call adjust values. And again, that's happening by you pressing the select button on anything but the end row or the first row. The first row being 0 and the end row in our case being max rows of 4. So that's swapping the menu lock, and that's taking the menu home when you press the select button. The up and down button is swapping the float interval and the int interval state, and checking if the menu lock is true or false, and calling a different array accordingly. So as I said, the menu lock is false by default, so if I've pressed up on the buttons, menu lock is called. Sorry, menu navigation is called. To which it says, menu row equals adjust int, menu row 0 max rows. If we look at adjust int, this is a function that we can call over and over instead of having to write repeatedly if the value is less than max value, or if the value is greater than 0, or whatever your minimum value is. We have a function that we can just call over and over. One for a float, one for an int. This int can also be used for a byte, a bool, a long, whatever you wish. Again, they have their own increments. So when we press up or down with menu lock set to false, the menu row is adjusted with a minimum, a complete minimum of 0 and a maximum of the max rows being 4. And that will say if the float interval, if the int interval is less than 0, so in our case it's set to -1 if you press down, and the value, in our case menu row, is greater than the min, being 0, value, which is many row, plus equals the int interval. And you're probably thinking, well, how do you go backwards if they're both plus equal? Well, again, it's set to -1 if you press down, being less than 0. So, for instance, the value of many row could be 2. So 2 plus equals -1 would be 1. 1 plus equals -1 would be 0. 1 plus equals 1 would be 2. 1 plus equals 1 is 3. There. Sorry, I said that wrong. Anywho, you understand what I'm saying. We're using a plus equals here, but this could be positive or negative. And then we're returning the value back to the statement. So many row equals adjust int, being this, an int itself or a float accordingly. And if the many lock is true, so we've pressed this on either of the rows, we would then call adjust values, to which it says the same kind of statement. If many row equals 1, 2 or 3, again many row 0 is home, many row 4 is exit. You've only actually got 3 rows to which we're displaying values, to adjust that is. Testball equals adjust int 0 and 1, to which testball is obviously a boolean. We've got a byte and a float, so that could either equal false or true. Our test byte, again we can do any type in here, is adjust int test byte 0 to 255, and we've got a float as well, to which we could say, for instance, the minimum of -10 and a maximum of 99.99, to which we can change the increments. We could have this change that at runtime if they've held down the button for so long. I shall show this compiled and running, which helped upload it, wouldn't it? So again, we've got 4 rows. We start at row 0. If we press down, obviously it won't go any lower because we're calling a minimum of 0. And we can go up to menu row 4. If I press select, it's taking the menu home, which is what I was describing there. If the menu row is greater than or equal to max row, we're saying greater than or equal to. Really, that could just be equal to like that. But just for good practice, in runtime, somehow the user managed to spam the button so fast that it did it twice, which it couldn't because this is procedural code. But still, if it did, then the menu could get stuck. So it's kind of just good practice to have a greater than in case it goes out of bounds. Again, that shouldn't happen, but just in case. So we have 4 rows defined in this example. As I said, if you go up to the maximum row, it takes you home. So if we go menu row 1 and press select, we will see that we have a boolean on menu row 0. If I press up, it should go no higher than 1, which is true, as in the state is true, and 0 for false. And I press select again, we're now back in the menu. I can go up to row 2, to which we have a byte. Its default value was set to 10. Again, we can't go any lower than 0. And we can go up to 255. We'll go out of that, and we're going to row 3, to which we're calling the adjust float value. And you can see it's incrementing in 0.1s, which is our default float value. Press select again, we're back in the menu. We can return. And that's essentially a simple 1-layer menu.
Sorry, I don't know that one.
Oh, silly. Um, and of course, to display the data, we have our menu function, to which this is constantly refreshing. So on your home page, you could display whatever you wish with an LCD statement, an OLED, TFT, whatever your graphics library you're using. You just put in here what you wish to display. And for our next 3 rows, you'll see that there's 2 different parts in here. So if, again, this is the default, menu lock is false. If you're incrementing through the menu, so when you've just started it, this is what you'd see. You'd see the home page, you'd see this part, and this part. Unless you press the select button on row 1, 2, or 3, you would see a second row because you have a row for many not equals false and a row for many not equals true, to which I implement a title. So for instance, you could have your home page, then you could have temperature, humidity, um, display timeout, and return, to which you then have the value to adjust here. So when you're pressing select, you'll see your value here to actually, which you're actually adjusting. And this is your title, home page, and again your return. A nice, simple, and very quick to adapt menu. All you need to do if you want to adjust more rows is just change this number, add some more rows in here, just literally kind of copy and paste it, copy and paste however many you want. You could actually change that for, it's me just being silly. You can change that for that, so it's even quicker to change. You just copy and paste those a few more times. And in here, this stays exactly the same. You don't need to touch this at all. It's completely, um, what's the correct word for that? We'll just call it completely modular. This stays the same. All you need to do is just change this. So let's say I want to change this to 10 rows. I'd then copy and paste that till I get to the number 9, because that's the 10th row. And I'd add however many more rows in there, up to row 9 again. And that's it. And you've essentially added all the rows you need because it's all worked out by the max row and the row you're on. You're probably thinking though, well, I need a bit more rows than that. Not essentially this many rows, but you want more rows inside these rows. You're thinking, well, that's not necessarily enough. Well, I have a couple of examples where not only do you have a value for just one row, but then you have a sub row inside there. And then I have another example where you have a sub row inside there. So essentially you have a menu where you have, let's say, 10 rows. And then in each side of those rows, you could have however many rows, up to 255. So you could have 255 rows with 255 rows inside those rows, with 255 rows inside those rows, with then the two final rows inside those rows. I'll show you one example. You're probably thinking, oh wow, that sounds complex. Nope, only need two more variables and a couple of if statements. I'll show you. So let's go into a two-layer menu. Here we go. Exactly the same, but we've got these two rows here, two new variables here, which is a variable to keep track of the subarray, and an array to define the amount of subrays we want within each menu row. Again, because we've got four rows here, row 0 is the home page, row 4 is return, so we have 1, 2, and 3 to adjust variables, to which we only need an array of 3, defining the maximum amount of rows for those 3 adjustable rows. You understand what I'm saying? I hope. I've created a few new variables, 7 in fact, I think, or maybe 8. 8. 8 new variables. Everything else here is the same. The menu now looks quite different. I shall show you. I've marked where it all begins. So what it is saying is, again you have your home page, then you have row 1. Within row 1 you have the default row, so when you're incrementing through the menu, you haven't pressed anything except for up, let's say. You've started it and you're just pressing up. You'll see the home page, you'll see the title here, so this could be your doser values. This could be a settings page. This could be a warnings page. Do we have a subrow 4? Yeah, and this could be an exit page, obviously. Within your doser page, you could have, you obviously have your things. So let's say this says doses. Then here, you'd have doser 1, doser 2, and you'd have the value for doser. Let's say this says 100 mils, this says 200 mils, and then this would say that would just say menu back. In my case, I just implement a return icon. And then let's say you have your settings. Yeah, this would say settings. And then you could have settings number 1, which could be screen timeout. Then you could have disable beeper. And then you could have disable LED, calibrate temperature, um, renames doses. I normally have about 10 rows within my settings. Then you could have your warnings, warning 1, warning 2, warning 3, and again return. You'll be surprised how many rows you actually need for a full-fledged product. I normally have about 12 rows, with about obviously 10 rows inside that, ranging between 6 to 12 rows inside there, so you can calculate it to be about 200 rows in a menu. Again, very quick to change. I'll show you what needs to be adjusted here. This is exactly the same. This is exactly the same. The only thing that's really different is these two parts, the select button and the menu navigation. Within the select button, again it says, is the menu row greater than 0? Then it says, are you at the end of the menu? Let's say this is false. This is like the same as the last uh, example I showed you. So, are you at the end of the menu? If you are, return the menu. Else, if you're at the end of one of the menu sub-rows, again this refers to the array. So, if we're at row 1, because we're greater than 0, sub-rows 1 minus 1, so sub-rows 0, an array starts at 0. This has a max row of 3. So, we can go up to 3 before we press select, and it returns the sub-row home back to the menu to which you'd see the title. Else, if you're not at the end of the standard menu row or the sub-row, and you press select, set the sub-row to 1. Now, what that is doing is sub-rows by default is 0, and when you press this select, once you're in there, so you've pressed select once in the menu, that's now said you're not at the end of the menu. Okay, let's set sub-row to 1. When sub-row is set to 1, what happens is you've pressed up or down, to which it's then said menu navigation. It said, is sub-row equal to 0? Assuming you haven't pressed select yet, it's obviously just going to call the menu row. So it's going to do the same as before and just increment the menu. If you've pressed select, this is now set to 1, and it's going to increment the menu sub-rows. Same adjusting between a maximum of menu sub-row minus 1. So the same as here. So let's say you're at menu row 2. 2 minus 1 would be 1, so that would be array number 2. Blah blah blah. Print out a statement saying what row we're on, just for debugging. Else, if we're already in the sub row, so that's already set to 1, you're not at the end of either the sub row or the menu, and you've pressed select, set the menu lock to not menu lock, same as before. Menu lock equals not menu lock, so true equals not true, false equals not false. So in that sense, true equals false, false equals true. Add a bounce there, same as last time. And here in our adjust values, instead of just saying if menu row equals 1, 2, or 3, we're now saying if menu row equals 1, if menu sub-row equals 1 or 2, same here, 1 or 2, and because, just for example, I've set this to 5, here we have 4 rows. Again, row 0 and the final row, as I've noted here, 0 and the final row are not counted. So in our menu, we have included them all because this is the title, the 0, and the final one is the return. So when you're going through the menu, you'd see like a title saying settings, and then this would be the return at the end. And essentially that's all we've had to do. Create 2 variables and just 1 extra statement here and another statement here saying if you're at 0 and you press select, set it to 1, and if you're at the end of the menu, return it home. If you're set to 0, call the normal menu row. If you're set to 1, call the sub-rows menu. I'll show that running. I'm probably terrible at describing this. but I assure you it is quite simple. I'm sure a lot of you will just download it before getting to the end. 1, 2, 3, 4. Again, we've got between 0 and 4. You can see here I've set the minimum as 1. I don't actually like you going into the menu and then just pressing backwards to go out of it. I prefer you actually use the menu return page to return the menu. So let's say you go in row 1, we should have 3 rows. So I press select. We have 3 rows because that's how we defined it, with a minimum of 1 and a maximum of the sub row, menu row -1. So if we're on menu row 1, get the array 0, which is 3. So we have 3 rows. If I press go to the third, it takes us back into the normal menu. So let's go back to 1, press select, and let's just go into menu subrow 1. And now we're adjusting that int value, which, if you actually have a look in our adjustments, is a boolean. So we've got 0, 1, which is great. And we're going to row 2. We've got this, which is set to 10 by default, same as earlier on. Row 3 is the exit. Row number 2 is adjust a float. So let's go to 1. Yep. Number 2 is adjust an int, which is by default set to 1000. Again, you can see here it says you can adjust it from 0 to 1000. So I set it to 1000 just to show that it would stop there. Go out of that, return it. Then we've got menu row 3, to which we've got 5 rows. On the first row, we have a byte interval. Again, that could go to 0 to 5. Then we've got another float, sorry, and int again. You can see that even if I'm pressing up, nothing's happening because I purposely set it beyond the range, 1500, and this is saying you can't go any higher than 800. So even if we're pressing up, nothing will happen. We can only go down, which is what we want. And then number 4, another boolean, true or false. True, false. And that's our menu. Go home, and that's it. You can easily implement a few other cool features. So because we're using an if-else statement here to check the button statements, we can then do an else at the end and have a simple timer. So we could have just 1 byte, sorry. I'll just explain this very quickly. This is for another video. Byte AFK time. And we can use this to return the menu if you're away for so long. And essentially, all you need to do is say, if you press this, set it to 0. Yeah, I'm sure you can already see where I'm going with this. So if you press any of the buttons, set it to 0. Else, here you want to use a timer, which you can get from, for instance, blink without delay. So I'll just show you that very quickly. I don't want to waste your time. We'll just pillage a lot of this very quickly. I'll put some other screen, I'll show you how quick we can do this. Right. So we want a function to check if the user has been away from the device, not pressing any buttons, and let's say we're within the menu somewhere and they walked away, we want the menu to return. Or if you're using an OLED display especially, you might want to turn off the display after so many minutes, and then when they press a button, turn the display back on. So we're going to need static undecided long, because this is within this loop. Static means that it's going to remember its previous state when the function was last called, and it can only be adjusted when it encounters an equal sign other than its initial declaration. So even though I've set it to 0 here, that won't be called any more than once ever. That may confuse you, but it's just the way it is. We're going to say so if current mils minus previous it's greater than interval, so we're going to have an AFK time of a second apparently. we may want to put that somewhere else that we can easily adjust it. And we'll call it something a bit better. We'll call it a user variable too, but we'll put it at the top because this is a bit more relevant. And we'll set this to, just for example, we'll set it to 10 seconds, and we'll call it AFK interval. As I say, AFK interval. AFK interval equals current previous meals. If current meals minus previous is oh, previous meals, you kind of idiot. And essentially what we want to do is, if no button equals high, current meals equal previous current meals. I haven't got my unso long current meals. I thought something was missing. There we go. If current meals minus previous is greater than AFK interval previous request, we've got a 10-second timer currently set there with our previous meal statement here, and our current meals is set there, our intervals on the home page. Now what we need to do is say if AFK time is AFK interval 100 seconds. If AFK time is greater than, oh no, we're gonna, yes it is, sorry. I wonder why I got confused there. We're just gonna plus it. We're gonna check it, but first we're gonna make sure it's within its range. 254 because it's gonna go one higher. If AFK line is less than 254, AFK previous measure, so I was constant long, yeah, I was right, so that wants to be 1 second. So that's going to be 1 second. Every 1 second, that's going to increment the AFK time. Unless you press from the buttons, it will go back to 0, to which we can then just have a simple function say, if the AFK time is greater than your timeout. So, for instance, you, well, it's also good practice. I'll tell you. Thinking about it now, we'll cut that out of there. We'll chuck that in at the top of here. And what we'd say is, if you press any of the buttons, not only will we set that to that, we'll set this to this. Because thinking about it, for the clever ones of you out there, setting that to 0 wouldn't be sufficient because the timer, that may set to 0, but then this may set it to 1 a millisecond later. So we really want to reset the timer as well as the counter. So we'll reset the timer and the counter if you press any button. If no button is pressed, the timer will run and it will check the AFK time, to which we can then make a simple menu function. Well, we'll put it in the menu, and we'll call it void timeout. Ah, thank you for your eager people still watching. And we're gonna put. I've seen the mistake I've made. Don't worry. We'll say menu home, AFK timeout, and we'll sort out that. Serial.println AFK timeout menu home, and because we've got this and menu summarize, we'll set them both to 0, and we'll set the menu lock to false because we want to essentially, and we want that to go to 0. AFK equals 0. AFK equals 0, and then we just want menu row. Where is our menu row? And of course, we want the timeout to be called here, and we want, so this is going every 1 second, which is our current interval. So we probably just want, you can change that to a minute, but because realistically you probably want that to be minute, which would be that. But for me, really I want it to be just 1 second, because I'm going to do this a lot quicker. And we're going to have a, we'll change that here. I wonder why I got confused later on. It's normally not where I'd put it. That would be a system variable, because that's a constant. And then we're going to have a menu timeout. So bool menu timeout. It's not bool, it's a byte. Menu timeout, and we'll set that to 10 seconds. So that's a second, 10 seconds. That's meant to be a byte. Byte, menu timeout. Cool. And that's not going to be a constant, so I would expect to change that in the menu. That would be one of my options to change. To which we're going to say here, if blah 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 equals that. So if AFK time is greater than or equal to menu timeout, take the menu home. And that's working, but that's constantly being called. The AFK time is incrementing any time the buttons are not being pressed. And it's got a maximum of 255, so it's 254 seconds in our case. To which we're saying if the AFK time is greater than 10, okay, it's 10 seconds, take the menu home. So let's show that going. Oh, previous meals was not declared. Have I not declared it? Apparently not. Have I cut it out? Current meals? I had it in there. You little bastard. Ah, I put it in the wrong part. Oh, no, I see. I wanted to put that there, didn't I? Check it there. Cool. Where's my serial monitor hiding? Cool. So, take that to row 1. Get my timer out, it's a bit late. To which this should be getting called now, because no button state is high. Current meals minus previous. Yep. Menu AFK, menu home. And we're back to row 0. And again, in this statement, I normally chuck a statement saying display asleep equals true, to which in the timeout I would then say if display equals true and AFK time is less than AFK timeout, turn the display back on. Quite simple. So that's a menu timeout function as well. And again, I've showed you how to do a 2-layer menu, to which you could implement hundreds and hundreds of rows. It's very rare that you need a 3-layer menu. I should attach it in this video if you do wish to implement 3 layers, but I'm not going to go into detail explaining it because essentially it's just the same process of converting a 1-layer menu to a 2-layer menu, but putting the 3rd layer inside the 2nd layer. Yeah. Yeah. So I hope you found this useful. There's loads of little tips and useful little things you can use in it. Efficient ways to adjust variables and change states without having to repeat yourself loads of times. Again, this menu design is extremely modular. You only need to just add more variables to adjust and adjust the menu, along with obviously changing that to suit the number of rows you wish, to which you then change the amount of rows you wish within the sub-rows. Again, hope you found this all useful. Thanks for watching.